I'm going to talk a little bit about a shale technology application. This is not bear with me, this is not an asset management example, but I thought it'd be another typical type of example of the way we're working very differently in our industry. You can see the way that we do this kind of work. We drill those wells, we drill them horizontal. This is the fracking part where we perforate right now is what you're about to see. We shoot shrapnel basically out through the casing and the cement, and then we pull that gun back out and we come in and we pump sand and water. The sand is called proppant. I don't know why they call it proppant instead of sand, but it's sand. I never knew there were so many different kinds of sand in the world, but apparently there are very, very special kinds of sand. Some make good proppant and some don't, and there's a whole science and argument around that. Anyway, this is fracking in a very simplistic way. This is what you may read about as, various opinions about good or bad. But being able to do that allows us to produce this oil out of a much higher surface area of the shale rock, which is fundamentally what made this economic for us. We still only produce 15 to 20% of the oil in place. Even with all this amazing technology, we're still only accessing 15 to 20% of the oil and the hydrocarbons that are actually in that rock. In the past, when we did this drilling, and I'll jump to the next slide, it's incredibly complicated. So that picture makes it look like we're drilling into a nice, cookie sandwich, right? But it isn't like that. You can see at the top there, the squiggly line is actually the little dark line that goes through the yellow and the orange. That's a well that we landed exactly in zone, 99% in zone. So in zone is not a nice straight line. It's actually a very complicated thing that we optimize in real time. And actually, this is an example of the subsurface model. So I joke with people that really the only thing we're trying to do in the oil and gas industry is create a high-resolution model of the Earth's crust. And if we can do that, then we'll actually be able to beat the competition, because the higher resolution model I have of the Earth's crust, the better I know where to land a well and how to develop oil from that well. It is the biggest big data problem there is out there. So we do everything we can to try to develop a very accurate model, but as we drill that model, we learn, and that model changes in real time. It used to be we developed a well plan. The well plan was handed from one department of our company to the drilling guys. The drilling guys would drill the well plan, and we would find out that we were only 70 or 80% in zone once we figured out that the zone that we thought we were landing in was really not where we thought it was. In fact, it moved on us. It didn't move. It moved 1 million years ago, but we didn't know where it was, or more, 150 million years ago. You can also see that what we're trying to do is drill around a bunch of other wells that are out there. If you hear about all the development that's going on in the Permian Basin, there are hundreds of vertical wells that are producing oil out of the same formations that we're drilling into. So imagine trying to drill through a spaghetti bowl of other wells and land exactly in the target zone that you're trying to drill in, which is not a nice Oreo cookie sandwich. In order to do this, we absolutely started with the basics. We just said we need to get data, we need to organize that information, we need to get a cross-functional team. We created a well construction decision support center. In this center, we have the geologists, the drillers, the completions engineers, operations input in terms of what will work and what won't, in terms of pad layout and that sort of thing. They manage this real time. We get sub-second data off the rig. We used to not get data except sort of manually input data on a daily basis, and usually a much more detailed download on a weekly basis. We now get real-time sub-second data and full downloads from the drill bit. You can't get all the data off the drill bit except when you pull the pipe out of the hole, which is a huge problem. To do that, it's very expensive, waste of time, so you want to do that as little as possible, but we can get some data real time off of the rig, both the rig information like torque at the top, and there's some ways that we use the mud. We actually do sort of sonar through the mud and get some low-res data real time as well. Started off with just basic data visualization. Where are we? Where are we going? As best we can tell. And then we realized that actually a lot of the instrumentation we have on these wells is 90 feet behind the drill bit, the tip of the drill bit. So if you think about 90 feet, I don't know if it's here past the back of the wall, 1 or 2 degrees off, and you're completely out of zone. So we built a predictive analytic model to tell us, based on where the instrumentation is, where's the drill bit. And we got incredibly accurate with that. Again, statistical analytics, using all the data that we were pulling in real time. Then we started looking at optimizing the landing location of the well. Again, updating our model based on looking at mud samples and what are we actually seeing in the drilling process in terms of the rock properties changing as we go through. So This process of developing capability in the WellCon Center for us has led to us being able to hit target 99.5% of the time. We've taken 30 to 40% out of our capital costs in drilling wells because we're being able to execute our drilling programs that much more efficiently and effectively. We're having fewer issues like broken, twisted off bits and stuck pipe because we're able to look at torque and location in the well. So again, the points are the efficiencies that have come from this are absolutely game-changing for us in our industry, and certainly a huge part of what's making us, well, allowing us to stay in business fundamentally anymore, but making us competitive and we think a leader in what we do.